Last class we did why there is need to define two specific heat in case of gas. Define the following. First, principal specific heat at constant volume. Same as specific heat capacity definition, we have to start with minor changes. The amount of heat required to raise the amount of heat required to raise the temperature of unit mass of gas. See, we are talking about unit mass of gas, not unit mole. Unit mass of gas by 1 degree Celsius or 1 Kelvin at constant volume. Amount of heat required to reach the temperature of unit mass of gas by 1 degree Celsius or 1 Kelvin at constant volume is called as principal specific heat at constant volume. Write this definition: principal specific heat at constant volume.
Answer.
Principal, second one, principal specific heat at constant pressure. Principal specific heat at constant pressure. Same to same word. Last it will be only in place of at constant volume, you will write at constant pressure. The amount of heat supplied, amount of heat required to raise the temperature of unit mass of gas. Only specific heat we were telling substance, because it is principal specific heat at constant pressure in case of gas. So we are writing amount of heat required to raise the temperature, amount of heat required to raise the temperature of unit mass of gas by 1 degree Celsius or 1 Kelvin at constant pressure is called as principal specific heat at constant pressure. Right. Completed? Hello, completed?
Yes, sir.
Okay. Third, molar specific heat at constant volume. Molar specific heat at molar specific heat at constant volume. See, capital CV we are using for molar and small cv we are using for principal. So we want molar specific heat at constant volume. Harshita, your video put it off. Molar specific heat at constant volume. Molar means for unit mole, and 1 mole is nothing but mass upon molar mass. So when we say 1 mole, that means mass equal to molecular weight. If this is 1, then mass equal to molar mass, which is called molecular weight. So the amount of heat required to raise the temperature, amount of heat required to raise the temperature of, now we will not say mass but unit mole of gas by 1 degree Celsius or 1 Kelvin at constant volume is called as molar specific heat at constant volume. The amount of heat required to raise the temperature of unit mole of gas by 1 degree Celsius or 1 Kelvin at constant volume is called as molar specific heat at constant volume. Completed?
Yes, sir.
Okay. Fourth one, molar specific heat at constant pressure. Molar specific heat at constant pressure. The amount of heat required to raise the temperature of unit mole of gas by 1 degree Celsius or 1 Kelvin at constant pressure is called as molar specific heat at constant pressure. Right. Completed?
Yes, sir.
Okay. Note right down how we are going to understand whether it is principal of or molar from the information. See, SI unit of principal specific heats will be joule per kg Kelvin. So whenever it is given value in joules per kg Kelvin, you can recollect it as principal because it is for unit mass. And SI unit of molar specific heat will be joule per kilomole Kelvin. When it is per mole or per kilomole, it is molar. When it is per kg, then it is called principal. Write this 2 point again. Done? 2 points.
Just a second, sir.
Okay, okay.
Done, sir.
Third point. Heat supplied at constant volume is mass into principal specific heat into change in temperature, or heat supplied at constant volume. For molar, it is total mole N into Cv dt. This is for 1 mole. So into N for N mole to change the temperature by dt is NCVT. Heat supplied at constant pressure is M into principal into dt. Total heat supplied for N mole is N into molar into specific heat into change in temperature. Write this for numerical. Okay, then
Yes, sir.
fine. Relation between molar and principal specific heats. Molar is for how many mole? Hello? Molar is for how many mole? 1
One.
mole. And principal is for 1 kg.
Yes, sir.
1 kg has got how many? 1 mole has got how many kg?
6
1
point.
mole. No, 6 point तो Avogadro number बता रहे ना.
Yes, sir.
1 mole is equivalent to molecular weight, no? When you say 1 mole of gas, that means molecular weight or molecular mass of gas. Okay? Hello?
Yes, sir.
1 mole means nothing but molecular weight. So, for 1 kg heat supplied is equals to principal specific heat into change in temperature. 1 kg into principal specific heat into change in temperature.
Yes.
Then for 2 kg, how much? 2 into principal into this much.
Yes.
For molecular weight, how much? M into principal specific heat, correct?
Mm.
And molecular weight means how many mole? Molecular weight is how many mole? Molecular weight, how many mole?
1 mole.
1 mole. So when I'm talking about molecular weight, actually I'm talking about 1 mole of gas. So we know that molar is for 1 mole, which is molecular weight. That means if small c comma capital C are principal and molar specific heats. We have not written at constant pressure or constant volume, just general. Are molar and principal specific heats. Then can I say molar specific heat is molecular weight into principal specific heat? Because principal is for 1 kg, molar is for molecular weight. So molecular weight into principal. I hope you all followed.
Yes, sir.
That is capital CV is molecular weight into small cv. Small
Mm.
means principal and capital means molar.
Yes.
एक मिनट. हाँ, हम लोग ने जनरल लिया है irrespective of pressure क्या volume, तो ये इतना. So if they ask you in one liner or in MCQ, molar specific heat is dash times principal specific heat. What you will write? Molar is molecular weight times principal. Okay. Hello.
Yes, sir.
Please write down. Though for 1 mark or 2 marks, they can ask you this in the exam. If you complete, please say.
Done, sir.
Okay. Please keep on revising at home. Because daily we are having lectures. You should revise also. So I can say that is molar specific heat at constant volume, molecular weight into principal, and molar at constant pressure is molecular weight into principal. Just copy these two more lines.
Done, sir.
YCP, that means specific heat at constant pressure, is greater than specific heat at constant volume. Why specific heat at constant pressure is greater than specific heat at constant volume. If pressure is constant, can volume change? If P is constant, can
No,
volume can change? No, P is constant. See, we are keeping P constant, volume can change.
Yes, sir.
And if V is constant, can pressure change? Yes, क्योंकि वॉल्यूम को कांस्टेंट रखा है, प्रेशर को थोड़ी. इधर
Yes.
प्रेशर को कांस्टेंट रखा है, वॉल्यूम को थोड़ी रखा है कांस्टेंट. So now
Yes.
let us see what happens when I keep volume constant and what happens when I keep pressure constant. एक छोटा सा heading written ना.
Yes, sir.
This multiplexes they have started function or not yet? Mayank,
Yes, sir.
multiplex it has started functioning or still it is locked down only?
Sir, lockdown only.
Achha. Suppose it starts in the month of April. First, I say, your all exams are over. I will give you one party so that you get charged one movie at multiplex. An early morning show where rate is bit cheap. The cost of one ticket was 200 rupees. This is sponsored by me. So minimum I should give you how much to see the movie? Minimum I should give how much to see the movie?
200.
Very good. 200 rupees I should give you minimum. If I give 50 extra, then you can come by auto depending upon nearness to your house, because extra I have given. If I have give 100 rupees extra, you may come out during break. कुछ नहीं खा सकते पैसों में, so something will add from your side. But can I say at least everybody has been given 200 rupees or not?
Yes, sir.
So same way in gas, if temperature changes by 10 degree Celsius or 10 Kelvin, then to change the temperature, whatever heat is required, that much to I have to give. लेकिन कोई एक्स्ट्रा भी कुछ करेगा तो एक्स्ट्रा भी देना पड़ेगा ना.
Yes, sir.
चलो अभी देखते हैं अपना ये कॉन्सेप्ट क्या, हाउ यू कैन अंडरस्टैंड. When gas is to be heated, you have to take in vessel, cylindrical vessel or rectangular vessel.
Yes, cylindrical, sir.
Fitted with frictionless, weightless, airtight piston. These are gas molecules. I want to keep वॉल्यूम कांस्टेंट, तो ऊपर से मैं प्रेशर बढ़ाऊंगा, एक्सपांड होने नहीं दूंगा. ठीक है, मुझे वॉल्यूम कांस्टेंट चाहिए. नहीं समझा?
समझा सर.
अभी इधर से इसको हीट किया तो क्या होएगा? गैस मॉलिक्यूल वो एब्जॉर्ब करेगा ना हीट. अगर एब्जॉर्ब करेगा तो मूव करेगा ना फास्ट, काइनेटिक एनर्जी डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. तो स्पीड से जाके इससे कोलाइड होएगा ना इससे.
Yes,
when it is colliding, it should expand, but we are increasing the pressure, not allowing to expand. If I am not allowing it to expand, whatever heat I have given, It has only increased the temperature. That means kinetic energy. That means internal energy. Okay? But suppose we keep pressure constant, not the volume. Pressure constant, not volume. So when we supply heat, gas molecule will hit this piston. Piston comes here. That means that volume has changed by this much amount.
Yes, sir.
And pressure P was kept constant. Volume को change होने दिया. That means the gas which is heated, it will absorb the heat to increase its temperature. इधर अगर 2 डिग्री से बढ़ाया, इधर भी 2, तो इसको अगर 10 कैलोरी लगा, इधर भी 10 कैलोरी लगेगा.
Yes, sir.
But along with that, it is expanding against external atmospheric pressure. That means it is doing work against external pressure. तो उतना एनर्जी उसको एक्स्ट्रा भी चाहिए ना to expand.
Yes, sir.
What is formula for work done? Is it force into displacement?
Yes.
Force, can I say pressure into area?
Yes.
What is area into displacement? Is it volume? समझ के बोलना बराबर. ये एरिया है और ये वॉल्यूम, तो P into dV becomes our work done or not?
Yes, sir.
Arshita, you followed?
Yes, sir.
That means when gas was heated at constant volume, only the heat supplied was used to increase internal energy. But when it is heated at constant pressure, then along with temperature, it is also doing work. That much extra heat it will take or not? No?
Will take, sir.
So heat supplied at constant volume and heat supplied at constant pressure are not same. Pressure वाला दो काम करता है. It is heat supplied at constant volume के जितना heat लेता है to increase the temperature plus does the work. So if I consider this is 1 mole for 1 degree, then this is Cp, this is Cv, this is dW. So Cp is greater than Cv or not by amount of work done.
Yes, sir.
Now this we have to write in proper words. Again I'm repeating, please be careful. The heat supplied at constant volume is only used to increase the internal energy. But heat supplied at constant pressure is used for two purposes: to increase the internal energy and to perform work during expansion against external atmospheric pressure. Therefore, heat supplied at constant pressure is internal plus work done. So for 1 mole of gas, if temperature is changed by 1 Kelvin, then this is Cp, this is Cv, and this is dW. So can I say Cp is greater than Cv or not? Now followed full?
Followed, sir.
Right, theory. When gas is heated, when gas is heated at constant volume, then heat supplied is utilized when gas is heated at constant volume, then heat supplied is utilized only to increase internal energy, that is temperature of gas. When you say temperature, means it is internal is kinetic energy. Next line. When gas is heated at constant pressure, then heat supplied is utilized for two purposes. First, to increase internal energy du. Second, to perform work during expansion against external atmospheric pressure. In bracket you can write D. Yes, done.
Just a second, sir.
Yes, no problem.
Done, sir.
So next line write down. Thus, heat supplied at constant pressure. Thus, heat supplied at constant pressure. In bracket you can write Cp is greater than heat supplied at constant volume. That is Cp greater than. Done, I think. Huh?
Yes, sir.
Now in your college they have done Mayer's relation. Obtain Mayer's relation. This in any of the college they did?
Yes, sir, they did, but they did not explain it well enough.
Okay. Obtain Mayer's relation for gases or show that Cp minus Cv equal to R. Write this heading. Obtain Mayer's relation for gases or show that Cp minus Cv equal to R. So if heading written, then tell me, I will clear everything in small.
Yes, sir, written.
Done, sir.
Okay. Very simple derivation. Just be attentive. I'm explaining and writing also so that you can understand it properly. This can be asked for 3 marks in the exam. consider 1 mole of ideal gas to be heated by temperature dT, to be heated to rise the temperature by dT, to rise the temperature by dT. Therefore, at constant volume, consider 1 mole of ideal gas to be heated to rise the temperature by dT at constant volume. Therefore, dq means heat supply, at constant volume will be Cv dt, equation 1. Any doubt in that?
No, sir.
Next one. When same amount same amount of gas means 1 mole of gas, is heated at constant pressure to increase temperature by Tt Kelvin, then dq P equals to Cp dt, equation 2. This heat is utilized for 2 purposes. This heat is utilized for 2 purposes. First, to increase internal energy denoted by du. Second, to perform work against external atmospheric pressure denoted by dW. So therefore, heat supplied at constant pressure is internal energy plus work done. Heat supplied at constant volume is same as increasing internal energy. So this is same as at constant volume plus work done. This is Cp dt. This will be Cv dt, because heat formula is mole into specific heat into temperature. So because it is 1 mole, so 1 into Cp dt, 1 into Cv dt, plus work done is Pdv. Just now explain how it will be Pdv. For 1 mole of ideal gas, can I say Pdv will become Rdt, because n is 1? Hello?
Yes, sir.
Pv is Rt, so Pdv is Rdt.
Hmm.
Therefore, Cp dt is Cv dt plus R dt. Throughout dt you can cancel. Throughout dt will get cancelled.
Yes, sir.
Therefore, we get Cp minus Cv is capital R. This is known as Mayer's relation for molar specific heat. Not followed?
Followed, sir.
Start writing. I think while writing also it will become perfect. If you don't understand anything, just tell me. Tomorrow again, same time is okay?
Sir, tomorrow actually we have Yogesh sir's lecture from 2 to 4.
So you tell sir, you should take from 3 to 4 anytime how we can keep when I already have fixed the lecture. This is first day I am taking lecture or from last week I am taking?
Sir, actually you used to discuss it one day before the lecture. So he told that he keeps from 3 to 4. Then one of the student also has class from 4 o'clock.
That
So
is
he,
not my lookout. I have already been keeping this lecture at same time so that nobody is disturbed. So you tell the sir to change the time. When you are knowing, I discuss for your betterment. But it is common sense I am keeping same timing only because I discuss so that you are comfortable. That doesn't mean that you will skip that timing and ask some other sir to keep the lecture. When you are knowing regularly we are doing the same thing. Or you should have asked me, sir, tomorrow lecture is there or not. This is the way how you should proceed. When you are knowing we are having regular lecture, and I told also by Sunday I will complete all syllabus by taking extra, but still you all didn't thought एक सर को फोन लगा के पूछूं सर आपका कल लेक्चर है क्या नहीं है.
he had discussed it on Friday only. So he's keeping only for CBSE and ICSE batch.
This is which batch beta? Same batch na?
Yes, sir. So I'll tell him.
Otherwise you suggest me time, which time you all are free. I will keep that time.
Will 6 to 7 work?
See, why we were not keeping because few students they have got problem na, during that time.
Or 5 to 6? I mean, if your permission says means
I think no, so I am ready to take at any time. You all tell me which time.
Sir, I'm okay with 5 to 6.
Dhruv, what time you are free, Dhruv?
Sir, I'm okay with 5 to 6.
Amay, you are okay?
Yes, sir, 5 to 6 works for me.
I to see Dhruv okay. Mayank okay.
yes,
Everybody is okay with 5 to 6.
yes, sir.
चलो लॉक कर देता हूँ. See, I just want till Sunday your help. That's it. Then I am at par everything.
Done, sir.
So Cp minus Cv equal to R. Can I clear this on the screen?
Yes, sir.
Yeah, can I clear, Dhruv? Right. This is Mayer's relation. This is Mayer's relation. This is Mayer's relation for molar specific heat. Mayer's relation for molar specific heat. Now, See, molar means molecular weight into principal, correct?
Yes, sir.
So M into principal, I can write capital Cp. M into principal, I can write capital Cv equal to R. That means Cp minus Cv is R by M. So this is Mayer's relation for principal specific heat. Copy 4 lines further.
Done, sir.
Right. Applications of degree of freedom on specific heats. Applications of degree of freedom on specific heat. See, heat supplied at constant volume is called internal energy. So that is nothing but for 1 mole it is CVDT, for n mole it will be n times CVDT, and for 1 mole it is 1. So internal energy upon dt, can I write CV by cross multiply? Hello?
Yes, sir.
Let us see what is meaning of this. How many types of gas we studied in degree of freedom? Mono, di,
Di and poly.
मोनो डाई 2 टाइप, रिजिड नॉन रिजिड. पॉली स्टडी नहीं किया, खाली बोला पॉली एटॉमिक भी हो सकता है ना.
Yes, sir.
सो फर्स्ट वन मोनो atomic gas. Simple, it is just sequence. Remember, it has 3 degree of freedom due to translational motion, correct? It has 3 degree of freedom due to translational motion. Therefore, its internal energy equals to 3 by 2 kBT, where kB is Boltzmann constant, T is absolute temperature. Clear? Hello?
Yes, sir.
Then we proved na internal energy is 3 by 2 kBT, है ना?
Yes, sir.
10 degree of freedom है, so total 3 into half, that is 3 by 2 kBT. Okay.
Yes, sir.
Now this was for one molecule. Monatomic gas, it has 3 degree of freedom due to translation motion. This was for one molecule, na? So can I say for 1 mole of gas internal energy U will be 1 means how many molecule? Avogadro number, correct?
Yes, sir.
So this is 3 kBt into Avogadro number. So U will become 3 by 2 R upon Na is called Boltzmann constant. Is it correct?
Yes, sir.
Into T into Na. So we can cancel Na. Now can I say du upon dt will be 3 by 2R by derivative? Okay or not?
Yes, sir.
This is nothing but Cv. I explained you how earlier, है ना?
Hmm.
ये समझ आया? Cv is 3 by 2R.
Yes,
Yes.
sir.
Everybody is followed. 3 degree of freedom. So एक molecule का energy 3 by 2 kBt. 1 mole मतलब Avogadro number का into Avogadro. K is nothing but R by Na. So इसका अगर change लिया तो change in energy up with respect to temperature is 3 by 2R. So Cv is 3 by 2R. Copy.
Done, sir.
Okay. Just 2 minutes, huh? So that I can wind up this part at least. Say I'm not skipping any topic. All the topics I'm taking, so extra lectures are required. Since Cp minus Cv is R na for 1 mole.
Yes, sir.
So can I say Cp is Cv plus R?
Hmm.
Cv we got 3 by 2 R plus R. Therefore Cp equals to 5 by 2 R.
Hmm.
Now adiabatic constant denoted by gamma is ratio of specific heat at constant pressure to constant volume. So 5 by 2R upon 3 by 2R. R by 2, R by 2 cancel. Gamma equals to 5 by 3. So important point we have to remember for MCQ or theory, for monoatomic gas adiabatic constant is 5 by 3. Sometimes they will give you different value of CpCv and they will say check for which value it is monoatomic gas. So you check ratio. जिसका भी ratio 5 by 3 आ गया वो monoatomic gas होगा. Complete till this.
Done, sir.
So that's all for today. This much you remember. Practice and come for the next class as per your